So following on from the previous two videos, we were trying to sketch this graph here, and then we would then differentiate this. So it's blah 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 blah. That will then take us to this here, and then by using this, we've established that there's something strange happening at x equals a half, and also something strange happening at x equals 0 here. So let's look at x equals a half. So now, well, we know that y prime, we set y prime to be 0. So we set this to be, we set this here, hang on, we set this here to be 0. So we try to find an x where this whole thing here would be 0. That would tell us where the gradient would be 0. Well, a half, when you put a half into there, it will give us a gradient of 0. So now let's put the half into the original function. That will then tell us where the turning point will be. Okay, so we know that something's happening at x equals a half. So let's put a half into the original function. So into the original y here. So here, put a half into here, and put a half into here, and then blah blah blah. That will then give you this. So what we know so far is that at x equals a half, here, the y value here will be this bit here. So the coordinates for this point here would be a half, comma, and then this number here, which is around here. Okay, so we know that it crosses 3 here, and we know that the gradient will be 0 here. So what we get so far is the graph will look something like this. Okay, so that's what we've got so far. So we know that the point will be here, and we know it crosses at 3. We know it's going to head towards infinity. Okay, so hang on. So now let's evaluate in the region. So hang on. If you look at this here, going back to here, hang on. So we know we've got a critical point at x equals 0. And then we know we've got a critical point at x equals a half. So now let's look at in the region. Let's look at the derivative in the region, in this region here. So from negative infinity to 0, and then later on we will look at the gradient in this region here, y prime in this region, and then we will look at the gradient in this region here. Okay, so that's our aim. So hang on. So, looking at our derivative here, so this is our derivative here. Let's look at what happens when the derivative is in the region. It's in this region here. So, as it turns out, the derivative will be less than 0 in this region, and then in this region here, it will still be less than 0. But then in this region here, the gradient will be greater than 0. Okay, so the way you find, well, okay, let's look at this bit here. Okay, so this here is our derivative. Now in a region where x is less than 0, so that's this region here. So if you put x to be less than 0 into here, so 2 times a number that's less than 0, this thing here will be a negative number. Okay, it will be a negative. And then you take away 1, then this whole thing here will be a negative number. Okay, so let's start again. So in this region here, where x is less than, where x is a negative number, so if you put x to be a negative number into here, 2 times a negative number, then this here will be a negative, and then you take away 1, so that will, then the whole thing here will remain a negative. Okay, and then you times 3, you times a positive 3, then overall this thing here will still be a negative. Okay, because a negative times a positive 3, it will be a negative. So at the top you've got a negative. Okay, but then this bit here, we don't really understand what's going on here. X to the power of 4 over 5. We don't understand what it means to have a power of 4 over 5. So we would immediately jump to 1. Sorry, we would immediately jump to, we would immediately jump to x to the power of a fifth, and then power it to the fourth. Okay. So we don't really understand this, but we would visualize this. Now, if you put a negative number into here, remember our graph x to the power of a fifth looks something like this. Okay. Now, if you put a negative number, so you're in this region into here, so this bit here will be a negative number. Okay, it will be a negative number in this region here, in the negative region. If you put a negative number into here, x to the power of a fifth will be a negative number. Now you've got a negative number times by itself 4 times, then that will mean it's a positive number. So this bit here will be a positive number, a positive in this region, of course. Okay, and then you times 5, then that will still be a positive number. So up here you've got a negative, and then divided by a positive. Then overall this whole thing here will be a negative. That's why our derivative is less than 0 in this region here. Okay, and then in this region here, in this region here, okay, let's select let's just randomly select a quarter, because a quarter is somewhere in between 0 and a half. Now let's just imagine you put a quarter into this thing here. So a half times a quarter, that will be a half times a quarter, that will be 2 times a quarter, that will be a half. Okay, so you've got half, take away 1, so this thing here will be a negative. Okay, will be a negative, and then you times 3, then the overall thing here will be a negative. Okay, and then again, we don't really understand what this means, so let's imagine to the power of this to be x to the fifth, and then times by itself 4 times. So if you put all right, let's look at this. Let's look at this graph here. That would then look something like this. Okay. Well, if you put a quarter into here, then that would be a positive side. That would be in the positive side. So you've got this thing here would be a positive, and then you times by itself 4 times. So this thing here would be a positive. Okay, and then positive times 5. Then the overall thing here would be a positive. So here you've got a negative divided by a positive. So overall the whole thing will be a negative. Okay. And then in this region here, you can use the same argument here. When x is above a half, this thing here will be a positive times a positive. Then overall it will be a positive on top. And then looking at this here, blah blah blah. This thing here will also be a positive. Therefore, a positive over a positive. Then in this region, y prime is positive. So this is what we've got so far. We know that the gradient will be going down. We know that the gradient's less than 0, less than 0. So that means it's going down all the time. Okay. So, well, whenever you have a negative and a negative, so over here is a negative and a negative, then there cannot be a turning point. Because in order for it to be a turning point, let's say you've got a negative here. In order for it to be a turning point, then on this side it has to be a positive. Then you can have a turning point. But here we've got downhill, 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 and then downhill, downhill in this region. So we know that from here to here it will be going down all the time. It will be going down all the time. And then on this side here, we've got something that's going down, 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 and then on this side here it jumps to a positive. So we've got a turning point somewhere around here. Okay, so overall your graph will then look something like this. Okay, because here you've got negative, 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 and then in this region the gradient negative, negative, negative. That means that the original function must be going downhill. So here you've got a negative, negative. The gradient will be negative, 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 and then a positive, positive gradient. So there must be a turning point here. So your graph will look like this. By the way, the reason why the derivative is undefined here is because of this. If you have a graph looking like this, hang on. If you have a graph looking like this here, the gradient here is defined because the gradient is really the up and down divided by the cross. At this thing here, the up and down here is 0 divided by, let's just say 3. You see, 0 divided by 3 is okay. It is 0. But if you have a graph looking like this, hang on. If you have a graph looking something like, hang on. If you have a graph looking something like this, hang on. Something like this here, the gradient, you cannot differentiate this because the gradient here will be, the up and down here will be, let's just say 3, the across here will be 0. So you've got the gradient where you've got the up and down, which is 3 divided by 0, is undefined here. The point I'm trying to make is that something like this, it is differentiable. Something like this here is not differentiable. It's not differentiable. Okay. So well, overall our graph looks like this, roughly speaking. Okay.